we have discussed ataupun we have studied about some of the terms that we usually use in thermochemistry. Okay, so it's more on the intro part of the chapter. Okay, and then next we have 5.2, the enthalpy change of reactions. Okay, so these are the learning objective that you should know. Okay, please make sure that at the end of this subtopic, you should be able to tick off this checklist. Okay, this learning objective that we have for this subtopic. Okay, so we have a lot of them in a lot of learning objectives that need to be covered for this subtopic alone. Okay, all right, so moving on, enthalpy change. What is enthalpy change? Enthalpy change is the heat content of the reacting system. Okay, so we denote this enthalpy change as H. H stand for enthalpy. Okay, so it is the total energy of a system at constant pressure that cannot be measured. Okay, enthalpy cannot be measured directly, and to be denoted as enthalpy, okay, the reaction ataupun the experiment must be performed at constant pressure. Okay, all right. For example, what is the enthalpy or heat content of 1 mole of sodium hydroxide or 1 mole of HCl? So this question cannot be answered because we cannot measure the enthalpy of the substance directly. Okay, we don't have the facilities for that as of now. Tak tahulah in the future nanti kita ada. Okay, but for now, we cannot measure the enthalpy of this substance directly. Okay, all right. So, however, the heat change or the enthalpy change, okay, which is the delta H of a system, can be measured when 1 mole of sodium hydroxide reacts with 1 mole of HCl to form 1 mole of sodium chloride and 1 mole of H2O. So this is a complete reaction. Okay, just now we only have a substance and we want to measure the enthalpy of that substance. So it's not possible. But what we can do is we can measure the enthalpy change when we react the substance with another substance. Okay, in a way we have a complete reaction there. So we can measure the enthalpy change, right? So thus the enthalpy change of reaction is the amount of heat or energy absorbed or released, okay, at constant pressure. It must be at constant pressure when the chemical reaction takes place according to its equation. So this is the equation that we have explaining this statement here. Okay, so for this system or for this reaction, we can measure the enthalpy change. All right, okay. So the enthalpy change of reaction is the difference between the enthalpies of the product and the enthalpies of the reactant. Okay, because it's the change, it's the delta. Okay, so delta means the change in enthalpy. So the enthalpy of the products minus the enthalpy of the reactant. Okay, so this is by right the formula ataupun to get the enthalpy, the change in something. In this case, the change in enthalpy of reaction. Okay, it is supposed to be the product of it is supposed to be the minus product of enthalpy of the product minus the enthalpy of reactant. Dia adalah hasil tolak. Okay, all right. And we also have the relationship, okay, to explain the delta H at constant pressure. The change of enthalpy is equal to the change in E, okay, the internal energy plus P minus V. P minus P, okay, multiplied with the change in volume. Okay, so this is the formula to determine the delta H of a chemical reaction. Okay, the original formula to determine the change in enthalpy. Okay, alright. So ini dia punya asal dia. Then we have these two equation. Okay, so this one we have discussed this in yesterday's lecture. Okay, in slide number 8, you may refer the slides. We have work is equal to negative P multiplied with change in volume. And also internal energy is equal to Q plus W. Okay, I've mentioned to you that the internal energy can be in a form of heat, and also in the form of work. So internal energy is the total of Q plus W. Okay, alright. So what happened is that, remember semalam kan saya cakap for the overview before kita start this subtopic, saya kata that for reaction, for chemical reaction, okay, the enthalpy change is equal to heat only. Okay, dia tak ada W. Okay, because E, Q plus W, tapi chemical reaction dia normally tak ada W, especially kalau the reaction does not involve any gas. So W will be 0. Okay, alright. So to represent the chemical reaction, special for chemical reaction, okay, we use H kan, betul tak? Enthalpy change, the enthalpy tu, kita guna enthalpy is equal to Q. Okay, so now kita nak proofkan macam mana kita dapat delta H is equal to Q. Kita nak proofkan dalam slide ni. Okay, cuba tengok. This one is the first equation, this is the second equation, and this is the third equation. Okay, alright. So next we are going to insert ataupun substitute 2 and 3 into 1. Okay, 2 and 3 into 1. So E is Q plus W. So kita insert into the first equation just now, and work, okay, P times change in volume is equal to work. Betul tak? Alright, so kita pun masukkan dia dalam ni. Dia jadi work dekat situ. So dia plus PV kan. So kita transfer negative to this side. Then baru is equal to PV. So now dia jadi negative work. Okay, alright. So W minus W, okay, we are left with Q only. Okay, so this is how we prove it. Okay, that the enthalpy change for a reaction, kita tak guna E because E supposedly adalah begini. Okay, ada work done by the system, work done by chemical reaction. Okay, alright. So since kita tak guna the W is not there, so we change the E to delta H. Okay, this one. So ini kita proofkan di mana finally, okay, the delta H is equal to Q only. This is applicable at constant pressure only. Kalau constant volume ke apa, if the pressure is no longer the same, that means it's not suitable. Okay, kita kena consider the work done. Kita kena check whether the reaction tu dia work, the system tu ataupun the reaction tu perform any work tak kat situ. Okay, so and then dia dekat constant pressure. If it's constant pressure and dia tak ada work done, that means the delta H is equal to the heat content of the system. Okay, alright, so we can conclude that the enthalpy change of reaction is equal to the heat or energy absorbed or released by reaction. Okay, is equal to the heat energy absorbed or released by the reaction. Okay. Alright, so these are the type of reaction. Okay, we have two types of reaction. We have exothermic and endothermic. Okay, I'm sure you are already familiar with this one. Okay, exothermic process is when the system release heat to the surrounding ataupun given off the heat to the surrounding. Okay, so it will be the transfer of thermal energy from the system to the surrounding. So what happened to the delta H? Okay, the change in enthalpy. So the value should be negative. Okay, this is to indicate that the heat content of the product is less than the heat content of the reactant. Okay, sebab ingat, bila exothermic, the system release heat to the surrounding. Okay, they release heat to the surrounding. So, apa nama tu, the energy of the system now, okay, is lesser than the initial state. Dia sekarang berkurang sebab the energy has been given off. Okay, so kita boleh kata during the reaction, we have reactant and product, betul tak? So during the reaction, the reactant has lower energy, the reactant has higher energy than the product. Ni reactant, ini product. Kejap. Sorry, terbalik. Ni reactant has higher energy. Okay, reactant has higher energy, product has lower energy. Kenapa product has lower energy? Because initially reactant has higher energy and then they give off they release the energy. So that's why bila energy has been relieved, okay, the product has lower in energy. Okay, the product has lower in energy. So that's why dikata dekat sini the heat content of the product is less than the heat content of the reactant. Okay, all right. So example, we have combustion. So combustion is very common. Okay, we can apa nama tu feel ataupun experience the hotness of this combustion process. Kita rasa panas kan bila kita menggoreng ke, bila kita membakar ke, kita barbecue ke, kita boleh feel the hotness ataupun dia punya release of heat. Okay, sebab the system release heat to the surrounding. So we could say that the heat is also one of the product produced from the reaction. So nampak tak? Heat for exothermic reaction is placed on the reactant side. It's the byproduct of the process. Okay, and then how do we represent the enthalpy? So the enthalpy change should be placed on the right hand side of the chemical equation. Okay, all right, so since this is an exothermic reaction, that means we should have negative value there. And then, guys, please take note, okay, this whole thing is this chemical equation, including the enthalpy change, is what we call thermochemical equation. Okay, so normally we would only have the equation saja without the heat, without the enthalpy change. That one is a normal balanced chemical equation. But if the question mentioned, right, the thermochemical equation for the reaction, please make sure to include this delta H on the right hand side of the equation. Normally dia duduk sebelah kanan lah. Okay, melainkan tak muat ke kita ke bawahkan dia lah. Tapi dia straight kat situ. Okay, that is what we call thermochemical equation. Right, so opposite to exothermic process, we have endothermic process. Endothermic process is a process in which heat is supplied by the surrounding to the system. That means heat is absorbed. System absorb the heat from the surrounding. Surrounding lost the heat. Okay, all right, so the delta H will be positive value. This is to indicate that the heat content of the reactant is less than the heat content of the product. So again, imagine a reaction, we have reactant and product, right? So we know that this is an endothermic process. So the system will absorb the heat ataupun the energy, right? So initially, the reactant has lower energy, okay? And then later, dia akan absorb the heat. Bila dia absorb the heat, the heat content of the product is higher. Okay, is higher compared to the reactant. Kenapa higher? Because it absorb the heat. So sistem sekarang ni ada extra energy dekat situ. So the value should be positive. Okay, alright. So look at the examples. So one of the reaction that is endothermic is decomposition reaction. Okay, di mana the substance will decompose into uh, few substances ataupun few compounds dekat sini. Okay, so calcium carbonate in solid state plus the heat because the heat is required. So heat is one of the reactant. Okay, in order for the reaction to take place, the heat is required. If not, the reaction will not be carried out. Dia tak boleh sebab tanpa heat is needed for decomposition reaction, heat is needed to break down the bond. Heat tu digunakan untuk break down the bond. Okay, alright. So dia akan break the dia akan decompose and forming CaO and CO2. Okay, so this is the amount of heat required. Alright, okay. Okay, and you have to be able to represent the thermochemical equation ataupun the exothermic or endothermic process by using energy profile diagram. Okay, so this is one of the, I would say, among the commonly asked question in the exam. Okay, kalau dia tanya soalan ni, bersyukurlah sebab dia senang lah, tapi you mesti make sure that you label everything, okay, and then you get the shape of the graph correct, and then dapat full mark dekat situ. Okay, alright. So how should we draw the energy profile diagram for an exothermic reaction? Okay, bila you kena draw graph, you kena ada axis. So axis dekat situ kita akan award mark. Okay, alright. So the correct label axis will be awarded 1 mark. Okay, 1 mark will be awarded for the correct and well-labeled axis. Okay, so kalau ni dia punya tu adalah enthalpy. Okay, the y-axis it should be enthalpy ataupun you boleh letak juga H. Okay, or bukan or. For x-axis, okay, it should be reaction pathway ataupun reaction progress. Okay, in a way dia macam time lah, dekat sini kita letak time. Tapi kita tak nak letak time because kita tak mau record the time. Kita tak mau record the time, 5 minit, 10 minit, 15 minit kan. Tapi kita letak progress because we know that the reaction will progress. Okay, so over time the reaction will progress. So kita tak payah letak time kat situ. Kita boleh letak reaction pathway or progress. Okay, alright. So the characteristic of exothermic reaction, the reactant, the energy ataupun the enthalpy, okay, the enthalpy ataupun the heat content of the reactant should be higher than the product. Okay, so make sure you label the reactants and product. So the heat content of the product should be lower than the reactant. Kenapa? Because the heat has been given off. Dia dah buang heat. So that's why the product has lower in energy. Okay, and then you have to have this bukit. Bukit ni. So this bukit is what we call activation energy. So you have to label it as EA. And then make sure that you start from the reactant. Okay, reactant dekat sini and then going up to the top of the hill. Okay, so that is the EA. EA adalah the minimum energy required for a reaction to occur. So every reaction has its own EA. Okay, every reaction has its own EA. Dia macam you kena lalu these halangan, these challenges, okay, in order for you to form product. So dia ada minimum energy required. Okay, it's like macam you nak further your studies untuk degree. Okay, so in order to register for your degree studies, you tak boleh directly daripada SPM uh, terus pergi degree. Okay, so you kena ada foundation dulu ataupun matric dulu ataupun A level. So that is the what we call dia punya prasyarat dia kan. So itu kita boleh kata macam EA lah. Okay, kalau you tak lepas the EA, you tak boleh overcome this, you fail ke ataupun you withdraw ke whatsoever, you cannot you cannot have your degree. Okay, itu memang syarat dia. Sama lah reaction ni pun. You need to have the EA. Okay, cuma EA tu dia tinggi ke, dia rendah ke ataupun sedang-sedang. Sebab ni adalah halangan. Okay, dia adalah challenge dekat situ. So, kalau dia rendah, senanglah nak naik. Kalau dia tinggi sangat, it will be difficult lah. That means we can imagine more energy is needed to overcome the EA. Okay, EA need to be overcome in order to form the product. Okay, alright, so label the EA correctly. So it should start from the reactant to the top of the hill ataupun to the top of the EA, bukit ni lah. Okay, and then how about delta H? Delta H should be the difference in enthalpy of reactant and product. Okay, you dah identify the reactant and this is the product kan. Alright, so the difference between these two is what we call enthalpy change. The enthalpy change. Okay, you kena label correctly Alright, so if we have this, katakanlah this is the equation kan. Is it? No, this is not the equation. Alamak, salah pula. Dia pakai NO2 Okay, katakanlah with respect to this one. Okay, kita guna CH4 in gas state plus 2O2 gas. Okay, and then CO2 gas plus 2H2O. This is the product. Okay, this is liquid. Okay, the delta H is given here. So it is supposed to be 890.4 kilojoule per mole. Okay, so you label everything on your energy profile diagram. So this thermochemical equation can be transformed into energy profile diagram. Right? Okay, so please take note that the enthalpy of the product is lower than the enthalpy of reactant. Therefore, that is why for the change of enthalpy for exothermic reaction, we got negative value. Okay, sebab produk dia punya energy lebih rendah daripada reactant. So bila kita tolakkan produk tolak reactant, we got less than 0 ataupun negative value. Okay, alright. Okay, moving on to endothermic reaction. So it's supposed to be opposite to exothermic reaction. Okay, make sure that you label. So correct label of Y and X axis. Okay, you dapat satu markah. And then shape dia. If it's endothermic, so this is how the shape of the graph should look like. Okay, so we have reactant and then we have product. As you can see, the product should have more ataupun higher enthalpy than the reactant. Kenapa higher? Because okay, the system absorb the heat. So the product will have higher energy than the reactant. Okay, and then how would you label the EA? Remember, EA dia kena daripada reactant, okay, sampailah dekat atas sekali, the tip of the hill. That will be your EA, you kena label. Jangan confuse nampak tak endothermic? Tinggi kan dia punya EA dia tu, dia nak overcome. So that's why it requires more energy compared to exothermic. Okay, tapi jangan confuse bila tengok exo ni nanti, dia akan start, student akan tend to tertarik kat bawah tau untuk exo ni. Okay, which is wrong. Dia punya syarat dia daripada reactant to the peak. Okay, sama juga this one. Daripada reactant to the peak. Okay, alright. So the enthalpy change would be the difference in reactant and product. This one. This is the enthalpy change. Okay, alright. So you should get the change should be more than 0, which is positive value. Okay, alright. Yep, this is the example H2O becoming H2O in liquid state. Okay, so this is the amount of heat absorbed by the solid H2O in order to form liquid H2O. As you can see, okay, it should be at normal pressure ataupun 1 atm, right? Okay. Classify the following reaction as exothermic or endothermic. Okay, question number 1, guys. Is it endo or is it exo?
Exo.
EXO.
Okay.
EXO.
Alright, boring kan soalan ni kan? Okay, how about B? How about number 2? Is it exo or is it endo?
Endo.
Endo.
Okay, aduh, of course lah soalan ni takkan ditanya dalam exam. Ni nak bagi warm up je. Okay, sketch energy profile diagram for each of the above reaction. Okay, do not refer to the previous slide. Okay, based on apa yang awak dengar dengan saya ni and then apa yang you boleh pick up. Okay, let's test your brain. Yeah, berapa banyak yang you sempat pick up daripada apa yang saya bagi tadi. Jangan refer, cuba try buat. Dapat tak full mark? Okay, alright, do it now. Jangan refer jangan buka slide yang sebelah tu based on apa yang awak tengok tadi yang saya explain tadi. Okay, I give you 2 minutes for that. Okay, alright. So let's go through the answer. Sketch energy profile diagram for each of the above reaction. So this is how you should draw your energy profile diagram. Okay, so usually 3 marks will be awarded for the complete energy profile diagram. Satu, markah pertama will be for the axis. Kalau betul-betul dua-dua betul, you get 1 mark. Okay, and then the correct shape of the graph. Shape maksudnya is it exothermic ataupun endothermic. Kalau exothermic, then kita akan check that the what do we call that, the enthalpy of the reactant should be higher than the enthalpy of the product. Shape dia. Okay, and then dia kena ada the EA. Jangan buat macam ni saya tak tahulah masa SPM ada belajar macam ni ke apa kan. Dia buat macam ni. Ya, ini memang menunjukkan dia adalah exothermic. Tapi what is missing here is the EA. EA tak ada kat situ. Okay, dia menunjukkan initially dia tinggi, after when the reaction has been carried out, the product has lower energy. So kita boleh tahu dia exothermic, betul. Tapi kita tak ada the EA there. Okay, so don't use this as your energy profile diagram. So you will not get mark for that one, for this one. So use this one. Okay, so kita ada info dekat situ. And then the EA you kena label correctly. So dapat, kalau shape dapat 1 markah, and then you label the EA dengan delta H. And then usually kita kena specify lah. Okay, so it's already given here kan. So negative 396, so negative 396 kilojoule per mole. Okay, alright. So kalau you dapat all of this correct, that means you got full mark lah. You get full mark for this question. Okay, and this is for endothermic. Okay, alright. So write the reactant and also the product and label the EA and the delta H. Right? Okay, moving on. Standard enthalpy. Do you have any questions so far, guys? Lupa pula nak tanya. Ada question?
So far no, madam. Okay.
Madam,
Yeah.
yang graph tu kalau hujung tu kita buat anak panah boleh kan? Buat arrow.
Buat anak panah? Macam mana?
Yang graph tu air-air tu kita buat anak panah. Biar kosong.
Lagi sekali tak dengar, tak clear lah.
Yang kalau madam tengok yang graph yang contoh ni dia tak ada anak panah, tak ada macam arrow kat hujung tu.
Hujung mana? Pak C. Okay. Tak apa, tak kisah. Asalkan dia ada, yang penting sebenarnya label. Label dan garisan ni. Tak apalah, you nak letak ke, you tak nak letak ke, tak apa. That is not major. As long as dia ada garis dan dia ada label. Kalau tak ada label, you letak ke, tak letak ke, you hilang markah. Okay? So the most important thing is the label, guys. Right. Any other question?
And the blue line, is it perlu kena wajib buat ke?
Blue line, this one. Tak. Okay, this is not necessary. As long as we can observe that you are highlighting the EA from the reactant, the enthalpy of the reactant to the top of the hill. Dah cukup. Tapi kalau you nak letak pun tak ada masalah. But this is again not important. You mesti tahu dia start daripada mana and then habis dia dekat mana. That is all. Okay? Okay. Nanti kan ada yang buat color-color bagus, tapi ikutlah kalau you rasa you selesa dengan cantik macam tu kan. Examiner suka tengok, tapi ada masa ke. Okay? Tu ambil yang penting-penting je lah. Yang mana yang tak payah buat. Kalau ada extra time, boleh color-color. Okay, buat matahari kat sini. Okay, ni ada matahari. Apa ni, matahari pun tak reti lukis, madam. Macam tu. Bukit kan. Right, any other question? Tak ada. Okay, jom. Standard enthalpy change. Okay, we have enthalpy change previously. Now we add in the standard enthalpy change. Okay, or it can be denoted as delta, enthalpy, H, and then naught. So this one represent the standard. Okay, all right, but before that, the enthalpy change of a reaction is dependent. Okay, so the enthalpy change depends on the temperature under which the experiment is carried out. And that means different temperature may have different enthalpy. And then it also depends on external pressure. Different pressure may have different enthalpies. Okay, physical state, and then the concentration, and then the type of allotrope of the substance. Okay, so these all will affect the enthalpy change of a reaction. If any of these are altered. Okay, for example, okay, nampak tak? Dia punya elements, the reactants and product are the same for reaction 1 and reaction 2. It's just that they differ in terms of the state ataupun the phase of the product. Okay, reaction 1, it is in liquid state. Reaction 2, it is in gas state. As you can see, look at the enthalpy change. It's different. The rest are all the same. The state is the only thing that we alter for the second reaction. And the enthalpy change is also different. Okay? All right, same goes to second example here. Okay, we have the same equation. It's just that the allotrope of the substance, which in this case the carbon, okay, both of them is in solid state. It's just that the allotrope jenis solid tu, arrangement of the molecular tu, it is in graphite state, and then the other one is in diamond state. Nampak tak dia punya change dia tu? This is 394, this is negative 396. Okay, alright, senang cerita, if you alter any of this equation, then by right, the delta H will be altered. Because this delta H is specifically for this reaction. Okay, alright. Okay, now baru kita go for standard enthalpy change. The reason it is called standard enthalpy change is because, okay, the enthalpy is measured at standard conditions. Okay, what are the standard conditions? So all reactants are in their standard state. Apa maksud standard tu? Standard is normally, saya boleh kata, kalau kata senangnya adalah dalam keadaan natural dia. Okay, by nature. Like for example, H2O by nature dia adalah liquid. Okay, oxygen O2, okay, dia dalam keadaan molecular and then in gas state. NH3, ammonia gas, is in gas state, not in liquid state. Okay, maksudnya by nature dia exist dalam keadaan itu. So that is what we call standard state. Okay, alright. So of course lah kita akan ada banyak sangat substance. So kita ada list dekat sini, kita ada table kat situ. Okay, to show the standard state of the substance, right? Ataupun elements ataupun compound. Okay, alright. So it's senang cerita, to be called standard enthalpy change, all the reactants are in their standard state. Okay, all the reactants are in their standard state, and then the temperature should be in 25 degrees Celsius, the pressure should be in 1 atm, the concentration, if it involves solution, the molarity should be 1 molar. Okay, if all of these are complied, that means kita boleh letaklah tanda bulat ni. Okay, we can call it as standard enthalpy change. If any of this is not complied, then kita hanya boleh pakai this one sahaja. Without the not. Okay, normally memang tak standard lah. Okay, ni mungkin okay, ni mungkin okay. But this one kalau involve solution. Okay, dia tak semestinya 1 molar. So kadang-kadang kita 0.5 molar ataupun 2 molar kan. Then it's no longer standard. Okay, alright. In order to be called standard, the standard condition must be obeyed. Okay, enthalpy change measured under these standard conditions are called standard enthalpy change of reaction, which is we have not, okay, addition of not on the delta H. So this involves the actual numbers of moles specified by the coefficient of the equation. Alright, okay, moving on. We have 3 types of enthalpy change, guys. We have 3 types of enthalpy change. Okay, kita akan start with enthalpy of formation first. And secondly, we have combustion. Thirdly, we have neutralization. Okay, so let's start with formation first. All right, so if it's standard enthalpy of formation, so we have to add in the F lah. Ataupun tak add in the F pun tak apa. Kita tahu from the equation based on the definition that we will go through. Kejap lagi Alright, so we use delta H not F. So the F represent the formation of the substance. Okay, how much energy is required to form that particular substance. Okay, alright, so let's look at the definition. So what is standard enthalpy of formation? Is the enthalpy change when 1 mole of a substance is formed. 1 mole of a substance is formed. And then it should be from its constituents element. Okay, dia mesti daripada elements, dia bukan daripada compound. Dia mesti daripada elements, whether it is molecular elements or atomic element, that one dia tak, stress on about that. Okay, instead dia hanya stresskan it should be in element. Okay, in their standard states under standard condition. Barulah boleh dipanggil enthalpy of formation. Okay, the change of enthalpy of formation. Sorry, bukan the standard enthalpy of formation. Kalau dia obey syarat ni, baru kita panggil dia enthalpy of formation. Standard enthalpy of formation. Okay, so the standard state of an element is the form that is the most stable at 1 atm and specified temperature. Okay, the reason that we want the we insist for the reactant to be at standard state is because it is the most stable form. Okay, at 1 atm and specified temperature. Okay, all right, so the delta H naught F for the element in their standard states are 0. Okay, for the elements, kalau dia adalah elements, that means dia punya standard state dia tu, dia delta HF formations are 0. Contohnya magnesium. Okay, normally lah oxygen. Okay, ni saya confirm oxygen. Okay, the formation of O2, the enthalpy change for the O2 to be formed is F is 0. Okay, nak form oxygen, it did not require any energy ataupun release energy ataupun absorb energy. So dia is equal to 0. Okay, untuk oxygen. That's why standard state for oxygen is O2 dalam keadaan gas, bukan O dalam keadaan gas. Okay, so oxygen present naturally as O2. Molecular, the molecular element in gas state, not O atom in gas state. If this is exist, that means dia requires energy, okay, to transform from O2 to oxygen atom only. That's why naturally oxygen present in O2. And then simple gases, okay, normally pun sama, delta. Dia nak form the gas tu is equal to 0. The formation requires no energy at all ataupun release energy. Okay, alright. Okay, jom kita write the thermochemical equation for MgCO3. Katakanlah in exam you are required to write the thermochemical equation that represent the standard enthalpy change of formation for magnesium carbonate. So how would you write the equation? Okay, alright, katakanlah dia bagi MgCO3. Okay, kita kena comply dengan whatever we have in the definition. Okay, alright, so we're going to start with the cara dia adalah kita start from the substance itself. Because they mentioned dekat sini, it should be 1 mole of a substance is formed. Okay, substance. Alright, so kita akan start MgCO3 in solid state. Okay, alright, in this topic, you must include the state. Without the state, mark will be deducted. Kenapa? State akan affect the enthalpy, the energy. So without the state, kita tak tahu energy ni represent tak the equation. So that's why without the state, markah akan ditolak. Okay, alright, magnesium carbonate is in solid state. Okay, you kena start from the substance itself and then buat arrow. Okay, next, okay, dia punya reactant. Reactant dia cakap it should be from the constituents elements. It should be from the constituents element. Okay, maksudnya bukanlah macam HCl ke, bukan CH4 ke, tak boleh. Those are not considered as element. Okay, alright, so macam mana kita nak check element dia? Okay, cuba tengok substance tu. Dia ada apa? Dia ada magnesium. That means we should have magnesium. Okay, so magnesium supposedly the standard state is in solid state. Okay, and then we do have carbon in the substance. So carbon. Okay, alright, we know that carbon can exist into allotrope, into forms. Okay, so normally it will be graphite. Sebab diamond dia ada energy dekat situ. So bila ada energy, requires energy, nak form the diamond itself, the standard state tu, it requires energy. So graphite dia 0. Dia tak requires energy, dia just form macam tu. Okay, dalam bumi kita ni secara semula jadi. So that's why it is graphite. Kena specify letak solid je, maka akan ditolak. And then Oksigen. Kita ada oksigen kan? Nampak tak? Ada oksigen there. So kita pun include O2. It should be O2, not O saja. Because remember guys, standard state, standard state, standard state. Okay? Yes. Sorry. Okay, next. You must make sure that it is balanced. You kena make sure that it is balanced. Okay, alright. So next, lastly, you have to check whether they balance. Of course, dia tak balance. Okay, tapi kita tak boleh ubah on the product side. Kenapa? Because in the definition, they mention that it should be 1 mole. Tak boleh usik on the product side. So the only thing that kita boleh alter is on the reactant side, the coefficient on the reactant side. Okay, alright. So kita kena make sure it is balanced. Sebab balance equation, nama dia balance because dia kena balance. Okay, macam mana pun kena balance. Okay, so how do we balance it? So magnesium need to, on the product side it is 1. So kita 1 lah juga. Okay, how about carbon? Carbon is also 1. Okay, settle, settle. How about oxygen? On the product side, we have 3 oxygen. On the reactant side, we have 2 oxygen. So how do we make it balance? Okay, so to make it balance, so we have to use fractions lah. Okay, kita kena guna fraction. Because kita tak boleh usik product side ni. So kita hanya boleh usik dekat reactant side. So later bila kita cancel out, kita darab, kita akan dapat 3 oxygen, which is the same as on the product side. So this is the enthalpy of formation. Bila you letak dekat sebelah ni, okay, berapa dia punya jumlah, that would be the thermochemical equation for the enthalpy of, standard enthalpy of formation. Okay, alright. Alright, so these are the list of element example ada banyak lagi. Okay, of course lah kita ada banyak, ini adalah example. Okay, the standard enthalpy of formation of some elements and compound. So like aluminium, so it exists naturally as solid. Okay, in standard state dia adalah dalam keadaan solid. So nampak tak the formation to form aluminium in solid state, it requires no energy at all. Maksudnya dia exist secara naturally, aluminium tu, maksudnya Tuhan jadikan tu, dia tak perlukan energy dan dia tak release energy. Okay, it's the standard state of aluminium when they exist in the in the world lah. Okay, dalam bumi kita. So bromine, okay, they exist sebenarnya dalam liquid state, not in gas state. Okay, and so on lah. Okay, nampak phosphorus phosphorus kita. Ni sulfur ni. Secara asalnya dia sebenarnya exist sebagai S8, bukan terus-terus jadi sulfur gas. Sulfur gas tu kita proses dia, baru dia jadi sulfur. So naturally dia, kalau dia nak jadi sulfur, dia maksudnya yang zero lah. We are talking about bila enthalpy of formation is equal to 0, it's actually S8. Bila dia S2, it requires energy. Okay, it requires energy. Maksudnya dia kena ada reaction dekat situ in order to form S2. So macam mana dia form, whether dia form kita buat dia jadi S2 ke ataupun naturally dia exist as S2 ke, itu another part of story lah. Because the enthalpy of formation will not be 0. Kalau 0, dia adalah sebenarnya S8. Okay, standard state dia S8. And then phosphorus, dia bukan phosphorus P macam tu dia standard state, it should be P4. You kena tahu ni. So maksudnya kalau you ada involve, contohnya you kena buat formation involve sulfur. So bila you buat equation, okay, katakanlah this is gas, you kena pakai S8, rhombic. Okay, sebab syarat dalam definition tu. Right? Okay. So another example. Write a thermochemical equation to represent the standard enthalpy of formation. Dia cakap formation of carbon monoxide in gas state. So tips saya adalah start from the substance itself, gas, and it should be 1 mole, and then buat arrow, and then kita identify apa elemen yang ada in the substance. So we do have carbon in the substance. So carbon, and the standard state for carbon is solid graphite. And then we have oxygen there. So the standard state of oxygen should be O2. Bukan O it should be O2 in gas state also. Next, kita balancekan. So, how do we balance it? Kita tak boleh usik. We cannot alter the coefficient on the product side. So, carbon is already balanced. Okay, oxygen is yet to balance. So, kita kena balancekan lah. So, on the product side kita ada 1, on the reactant side kita ada 2. So, nak balancekan dia 1, okay, kita kena tambah coefficient 1/2. Half lah ataupun 1/2. Okay. So this is our thermochemical equation to represent the enthalpy change of standard enthalpy change of formation. So kita boleh letak dekat situ. Berapa enthalpy dia? This one. This one lah. Kita kena letak kat tepi tu So kita boleh letak the formation dekat situ. Sebab kita check, dia follow dia punya definition. So here kita boleh letak formation. Kalau tak nak letak pun kita kena sendiri tahu. Okay, that this reaction is a formation reaction. Alright. Okay, so we have 2 checkpoints. Okay, so please complete this checkpoint. We will discuss it tomorrow during our lab session. Okay, S19 dengan S20 pukul 12 dengan until 2 o'clock kita akan ada additional lecture lah. Okay, kita akan sambung lecture kita. So please complete this checkpoint. Alright, okay, any question guys? Do you have any questions so far?
No.
No, madam.
Alright, so okay lah kalau macam tu. Okay, so that is all. So thank you everyone and Assalamualaikum.